Welcome, my dear JEE warriors, to the Vedantu JEE English channel, the #1 channel in English medium for all the JEE aspirants. And today, for all the 2026 and 2027 students, we are bringing you the lecture number 2 of circular motion. Yesterday, we have done kinematics. We did velocity omega, acceleration alpha, tangential acceleration, centripetal acceleration, and their relationships. Today, we are going to shift our focus to dynamics, specifically centripetal force, centrifugal force, that banking part, curved rods, conical pendulum, and all such kind of questions. I hope you are all geared up and all excited for the next session, my dear warriors. Hi, Jaitra, Sanjay, everybody out here. Let me know quickly if I'm audible, visible to all of you. This is your Captain Shreyas on the channel, my dear students. If you are new, subscribe. If you have subscribed, like the video and mark your attendance because your love matters to me for this channel to grow and to give me such amazing quality content right from the scratch to JEE level. I hope you guys are geared up, right? Hi Mukesh, good evening. Let's begin with the class and let me remind you, just 3-4 days are remaining. Just 3-4 days are remaining for the final registration. Smash that like button down there for MVSAT, Mega Vedantu Scholarship Admission Test. If you have not yet registered, this is your last few days. Not only will you get scholarships, but also national level ranking. And in your category, if you do well, prizes, lots of them from a pool of 2 crores. Okay. So the report card is also very fancy this time. So you better get going, guys. The syllabus is grade wise. For 11th, it is separate. 12th, it is separate. Droppers, it is separate. JEE, it is separate. NEET, it is separate. Even for 10th standard, 9th and 8th, it is separate. Okay. So many students have already registered. So make sure you are participating. It is going to be there on 11th and 12th of October. Okay. Just couple of days from now, it is going to be conducted. And you're also getting a lot of free resources the moment you even register for it. So you better not miss that particular chance for registering for MVSAT and participating in it. Okay. So I hope you guys are uh, registering for it as soon as possible. Hi Jalwant. Hi Akshit. Good evening. So let's talk about first the centripetal force concept. Yesterday we saw that if there is a particle which is going in a curved path with certain speed, then because there is a change in direction, as the direction changes, as the direction changes, as the direction changes, what should happen? Because the direction changes, therefore velocity is not constant. I will say that it has an acceleration directed towards the center. It is acceleration towards the center, which is called centripetal acceleration. And we saw that the centripetal acceleration is always towards that imaginary center of that circle or that curved path. So you can think of this as radii, and they are all meeting at one single place, and this is the center of that imaginary circle. So it is directed towards the center. That's what we saw in the previous lecture. As per Newton's law of motion, so according to as per as per Newton's laws of motion, if there is an acceleration on a particular mass, there must be a force acting on it. In our particular case, there is centripetal acceleration. So that force which is directed towards the center, this is then called the centripetal force. The centripetal force causes 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 the acceleration towards the center, causes the acceleration towards the center. So 100% there must be some force. Always the force is in the direction of the acceleration. Remember that. So there is 100% of force which is causing that acceleration. Without that force, it can't even turn. Impossible. The only reason why it is turning is because there is a force which causes that acceleration, which is responsible for that directional change. Now keep this in mind that this particular centripetal force, it is not a new force. This is very, very important. I'll put it in red. Note, it is not a new kind of force like gravitational force, spring force, normal force, frictional force. These are different varieties of forces. Centripetal is not a new force. Rather, it is the role which other forces like gravitation, normal tension, friction, etc. will play. It is a role which other forces will play. Very, very important. Rather, rather, it is, it is a, it is just a name, or I will say a role which is played by other forces like normal, tension, friction, etc. Normal, tension, friction, etc. I've seen many people show centripetal force as a force in the free body diagram. Completely wrong. Number one. Number two, I have seen people not even realizing that centripetal force is just a name given, rather they consider it as a new kind of force. So all these things are misconcepts. So let me explain this to you with the help of an example. Okay, so many examples are there to help you understand this. Say, we have a particle which is going on a curved path, and at some particular location, this particular mass which is there, it is experiencing multiple forces. Okay, maybe there is a force like this, maybe there is a force like this, maybe there is a force like this, maybe there is some kind of force here. Now, these are all different forces acting on that particle. What I will do is first think where the center of the circle is. So all I'm going to do is draw the radius, and this is where the imaginary center, this is the imaginary radius, I can say, of that circular path. All right. This particular path, this mass at that moment has some velocity, maybe v. All these are some random forces which are acting on it, forces acting on the body, acting on the body. What you do is resolve the forces into components along the tangent and along the radius, basically two directions. So whatever forces are there, I would say resolve it in two directions. One is along the tangent, other one is perpendicular to the tangent, that means along the radius. So for example, this force, the entire force will come over here as it is. Maybe this is F1. This force will have one component along this direction, maybe like this. This is, let's say, F2 in the y direction. Okay, let's say this was F2 force in the y direction. That F2 will also have some x component. This is F2x. Similarly, maybe this is F3. F3 will also have two components. One component over here, which is F3x, and maybe one component over here, which is F3y. Similarly, this particular force, let's say I call it F4. So that force will have one component like this. Let's say I call it F4 in x direction, and one component like this, which is F4 in y direction. The only thing remaining now is showing the acceleration. Remember, it is turning, so definitely it has some kind of acceleration towards the center. It definitely has some kind of acceleration towards the center. Now, just apply Newton's laws just like you would normally do in the Newton's laws of motion chapter. What would you do? once you have resolved all the forces, you will just apply Newton's laws of motion normally, right? Exactly, you have to do that, nothing else. Only in this direction. Forget the tangential, we'll talk about it later on after some time. Only look at the radial direction for now. Acceleration is towards the center, obviously. So I'm just going to put mass multiplied by acceleration over here. Mass multiplied by acceleration over here is equal to, left hand side will have the net force. So what are the forces? I think F3y is there. Can you see that? F3y is there. F4y is also there. So F3y plus F4y. Both these forces are towards the acceleration. F2y and F1 are opposited. So minus F2y and minus F1. That's it. That is your Newton's law equation. That is what you would do, everyone. अनुष्का एकलव्य टेस्ट का टीच पनुंगा इल्वा नो टीचिंग इन एकलव्य टेस्ट सीरीज इट इज प्योर टेस्ट सीरीज फॉर टीचिंग join the our sigma batch. Okay, for the teaching part, for theory part, sigma batch you should join. Okay, all right. Is it inertial or non-inertial? This is completely inertial frame, Rama. I have not considered non-inertial frame at all. Jevan, how come good morning, man? It is good evening, no? Oh, YouTube. No, no, no. On YouTube, we are not teaching specifically for the test series. You can watch my current lectures, whatever I'm doing, right? Same thing is being conducted as test series. Yeah, dates will not match, but if you see, I have started teaching right from the month of June after the JEE Advanced exam. So all these lectures and even my older classes, if you watch, theory set, yes, super, it will be, okay, in your head. Cool? All right, Anushka, just watch these classes. Now, if I ask you, where is centripetal force? Never ever show, oh, sir, centripetal force, sir. It is like this, sir. Wrong. Don't show like this. Number one. Number two, where is centripetal force then? The centripetal force is basically all of them together. So, this together is centripetal force. This together is basically centripetal force. So, centripetal force is necessary for that acceleration, and you know the value of the acceleration in the next step. You can substitute it as v square divided by r, or if omega is given, then just put omega square r. Okay, so no reason to say the value of centripetal force is mv square by r. I mean, it is, but don't think of centripetal force as mv square by r, or else you will think I should show one force as mv square by r. Lot of students do that. That is wrong, guys. Okay, no new force of mv square by r is there. It is a collective name given, which is a role which is played by these forces to provide that necessary acceleration. Is this clear, everyone? Have limit or constraint, Siddharth? Like, I mean, what kind of constraints are you expecting? Like for ranking, you should give it on that day itself so that you get a ranking. But if you give it later on, you will still get marks and report card without the ranking. Number two, these test series are meant to be conducted phase wise. I've explained what those phases are. And every test has some limited portion, and later on part test, and then we go to full test. That's it. Those are the limitations. I'm not sure what else you are asking. Okay. So let me give you one more example, my dear students. Okay. Very, very important. Let's see whether you can visualize this. Imagine there is, let's say, a string which is connected to this mass, and that mass is going in a circular path. This is our string and it is connected at a hinge. This is that mass and it is having some velocity. Because it is going in a curved path or it is going in a circular motion, I know it definitely has some kind of acceleration towards the center, but who will be giving that centripetal acceleration is what you should think. Well, it is this string which has a tension force. So I will say tension is equal to this particular mass into the centripetal acceleration. So this tension is the centripetal force. The tension is the centripetal force. And in the next step, if you want, you can write this as m into AC, where AC is nothing but V squared divided by radius or the length. That is what you will write in this particular case. Understood? Very simple, straightforward. Okay, I'll give you one more example. Imagine there is a Pandu. Imagine there is a Pandu, okay, and he is running, and suddenly he wants to chase somebody on that side. So he wants to turn suddenly. So for that, what he does, he grabs a pole nearby. There is a pole nearby. You might have done that in your school, and he makes the turn. Okay, he makes that particular turn like this. As you can see, again, Pandu, who was running like this, he has held the pole and then he runs like that. I hope you are able to visualize it. Why did he take the help of the pole? Because he wanted to go around, he wanted to change the direction. So when he tries to change the direction, obviously there will be centripetal acceleration. And remember, our centripetal acceleration is nothing but V square by R. The radius is small, his speed might be large. He wants to turn very quickly, and his speed is also very good. So, therefore, acceleration is also good. So, for Pandu's mass, and Pandu will have some good mass, obviously, he will need some kind of force. Now, who will that force be? Well, it is obvious he is holding the pole, so that pole will provide some kind of normal reaction on his hand. So, that normal reaction is that centripetal force. Centripetal force. So he's holding it, the pole pulls him towards the center, and that is why he's able to accelerate and change the direction. Is this clear? And you can see every example, the role of centripetal force is played by different forces like normal, tension, mg, gravity, okay, spring. Every time different force or a combination of forces might come, just like I've shown over here. Okay, very good. All right. How we can consider the direction? Yes, very important. Centripetal force as a whole will be in the direction of centripetal acceleration. Where is centripetal acceleration? Towards the center. So the net force will be towards the center, always. Net force. Individual one of the forces might be left, right, up, down. Like for example here, you can see F1 is not towards the center, but it is a part of that centripetal force. Okay, it is a negative part. You can say it is not helping in the centripetal, it is opposing it, but still it is a part. Okay, like in a group project, some people do work, some people do time pass. Although the time pass people are not contributing positively, but they are a part of that project or that group. So same way, these two gentlemen out here are not positively impacting, but they are negatively impacting, but still a part of the centripetal force. I hope this is absolutely clear, my dear students. So now that you are understanding what centripetal force is, I think we should now do some questions coming up on your screen. All right. Jevant, for fluids, I would suggest watch my Sigma batch class. Okay. If you're a part of Sigma batch, then good. If you're not, join it. All my lectures are there in that detailed. Number two, you can watch my old classes of nurture series. In nurture I have conducted, because I feel the time is very limited now for our JEE 2026 preparation. Maybe I'll have to do it as one shot in a couple of weeks. Okay, so I won't have so much time to do it lecture by lecture. So maybe if I do it, I will do it as a marathon or one shot. All right. All right. Yes, optical instruments is there in your syllabus, man. It is there in your syllabus. Okay. Yeah. 1 second, yes. Okay. So let's begin with the question coming up on your screen, and here it is. If the radius of a path of two particles of same mass is in the ratio of 3:4, then in order to have constant force, their velocities will be in the ratio of. To have constant centripetal force, what should be the ratio of their velocities. Okay, let's think how is force and velocity related. We know that our centripetal force is mass into centripetal acceleration, but centripetal acceleration is nothing but v square divided by r. So that is your centripetal force and velocity relationship. As you can see, the radius are in some ratio, and masses are same. Velocities ratio is asked, and they have same centripetal force. So what are the things which are different? Centripetal force is same, mass is same, velocity is different, and radius is different. So from this, I can just say v square by r is basically a constant. So therefore, v1 square by r1 is equal to v2 square by r2. And we have been asked the ratio of their velocities. So very evidently, I can just say v1 by v2 whole square. v2 goes down, v1 stays on the top, r1 will go on the top. So it will be r1 by r2. What is r1 by r2? The ratio of the radii are 3:4. So put 3 over here and 4 over here, but that is the square. So therefore, v1 by v2 will be root of 3 by 4, which is root 3 divided by 2. So root 3 divided by 2 is option number 1. Is nothing but option number 1. That is the correct answer. Okay. In the question, masses are same, force is also constant, and radius is different, and speeds are in some ratio. That is what the question was. Yes, very good, Rama. Very good, Manuva. Awesome. All right. Sure, Lone Rider. I will be starting PYQ series, guys. We will be ending this detailed classes before Diwali. I mean, just one more week from now. Today is 9th of October. So just few more days. That is next week, and few more days here and there. That's it. We'll be finishing off this series, and we will, whatever is remaining or whatever is important and needs to be done, and plus practice sessions is what is going to start after that. So make sure you're attending every single class so that you get everything in detail. Plus practice sessions, mock tests, everything is coming now. It's going to be next level now. Okay, cool. Let's begin with the next question on your screen. This was a JEE 2024 question, and you can see in many of my sessions I'm just also taking up the recent PYQs like 23, 24, 25. Some ball is there of some mass of some string length, it is attached. The ball is rotated in a horizontal path, vertical axis. The maximum tension in the string is 400. What's the maximum angular velocity? Let's visualize this. This is the axis. This is our string. This is our string, and the path is something like this. Maybe this is that horizontal path, and our mass is over here. This is that length, this is that mass, and it has some angular velocity, and that is what the question is, to find that angular velocity. Now obviously there will be some kind of tension in that string, and that acts like the centripetal force to provide the necessary centripetal acceleration as it goes round and round in that horizontal plane. So very clearly our centripetal acceleration into mass will be nothing but the tension force. But it is clearly mentioned what is the maximum value of tension. So I'll put 400 Newton over here. What is the mass? Mass is 0.5 kilos. Okay. And what is the acceleration? It is omega square multiplied by length. Omega square. Remember, acceleration is omega square into radius. Radius is length. So substitute the value of the length over here, which is 50 centimeter, which means it is 0.5 meter, which means it is 0.5 of a meter. Therefore, omega square will be 400 divided by 0.5 square. Therefore, omega will be root of this, root of 400 by 0.5 square. Root of 400 is 20. Root of 0.5 square is 0.5. So 0.5 is half. So 2 goes on the top. 2 goes on the top. So that is nothing but 40 but the answer will be in radian per second. So 40 radian per second, which is nothing but option number 2. 40 radians per second is the correct answer. So you cannot exceed that angular speed, because then speed is more, acceleration will be more, tension will be more, and there is a bearable limit of the string which will be exceeded, which you don't want. So that is why you will keep your angular speed lesser than 40 radians per second. Cool, guys? Yes, Rama, the answer is 2. Perfect. Yes. Sir, in Pandu example, isn't tension force? Uh, Pandu's hand is a part of the body. Pandu is not a string, so that is why wherever he touches the pole, there is a contact, and wherever there is a contact, there is normal force, not tension force. Got it? So that is why there was no tension. But if you treat Pandu's hand like a string, then in that string hand of Pandu, there will be tension. But we are treating Pandu as a whole body, and we are finding the force on Pandu. So the only place where it is happening in the horizontal direction is Pandu's hand. Okay, clear? Right. Yes, Manua, I am expecting the paper level to be difficult only. Although there was a committee which was set up to make the paper easy, but I doubt that will happen. That is chumma to fool all of you. And if it happens, it will be bad, because then all the scores will go up, which will not be good. A stone of mass 900 gram is tied and it is going in a vertical circle now. The previous question, it was horizontal. This one, it is going in a vertical circle. RPM is mentioned, length is mentioned, tension is asked when the stone is at the lowest point. Okay, let's draw, guys. Things are slightly different over here. Okay, things are slightly different because it is in the vertical plane. Okay, so this is my string like this. This is the mass over here. All right, this is the length. Okay, this is the hinge point. All right. And is the velocity given? No. RPM is given. That means omega is given to me. Okay. Omega is given to me. Now, if you see what are the forces, first of all, I see that there will be some kind of acceleration towards the center because it is going in a circular path. So centripetal should be there. Now, what are the forces? Well, there will be a weight. This is vertical motion, remember? So which is mg. And of course, there will be tension force. Apart from this, I don't think there will be anything else. Is that clear? Absolutely, everyone? Nothing else is there. So just treat it like a normal Newton's law problem where you write net force is equal to mass multiplied by acceleration. So what is the force? Tension minus mg or mg minus tension? Look where the acceleration is. It is upwards. So upwards is positive. If it was down, downward is positive. If it was right, rightward is positive. Okay, always forces which help the acceleration are considered positive. So tension and then minus mg, because it is opposing it, is equal to mass, which I'll assume it as m, and centripetal acceleration, which is omega square into L. This acceleration is centripetal. If you ask me, who is the centripetal force here? Then the answer is this whole thing is the centripetal force, which is providing the necessary centripetal acceleration. So this one is centripetal acceleration. Okay. So tension is not centripetal. Mg alone is not centripetal. Tension minus mg together is the net centripetal force. Okay. I hope this is clear. Just solve like a Newton's law problem. This is the crux of centripetal force, centrifugal force. Okay. Lot of students by heart something else. No, guys, just solve like a normal Newton's law problem. The only difference is acceleration is v square by r or omega square r. All right. Now it's just time to solve it. The question is to find the tension in the string. So therefore, tension will be mg goes on that side plus m omega square into L. So I can just take mass common, and this will be g plus omega square into L. So what is the mass? Mass is 900 grams, means 0.9. G value is 9.8, I believe. Okay. And omega square is asked. All right. So first we'll figure out how much is omega. Omega will be how much RPM is it given? 10 RPM. So if it is 10 RPM, I have told you how to do the conversion yesterday, multiplied by 2 pi and divided by 60. So what happens? 0, 0 cancels, 2 and 6 cancels. So it will become pi by 3, but in radians per second. So put pi by 3 radians per second over here. So pi square by 3 square, which is 9. And length, what is the length? Length, radius is 1 meter. Okay, perfect. That's it. Now it is clearly mentioned pi square is also 9.8. So this will become 0.9 multiplied by 9.8 plus 9.8 by 9. So this will become, okay, 9.8 is common and into 0.9. So 0.9 into 9.8 brackets. 9 will go on the top, 9 plus 1. 9 plus 1 divided by 9. Now 9 and 9 will cancel, guys. So it will become 0.1 into 9.8 multiplied by 9 plus 1 is 10. 10 and 0.1 will cancel. So it will be 9.8. But what are we finding exactly? We were finding tension. So tension will be 9.8 Newton. Tension will be 9.8 Newton. That is the answer. Got it, my dear students? Everyone? Very nice question. Okay, very nice question. Simple. Okay, you have to be very careful with the calculations because approximations were also given. So if you use the approximations correctly, you get a beautiful answer. Yes, great. So in vertical circular motion, you saw tension and mg both are playing role, but in horizontal circular motion, you saw it is only the tension which was playing a role. Okay, if it was horizontal, assuming the thread was flat. Cool. So this is how the questions are. Let's do one more question, guys. It's coming up on your screen. This was asked in 2022. Let's see if you can get this graphical part. A smooth circular groove is there and a block of certain mass is moving against the wall with a certain speed. Which of the following represents the relationship between normal and the speed of the block? Okay, let's understand why the block is going, what are the forces, is circular motion playing a role, how is it velocity related to the normal, all of it. If you notice, as it goes in a circular path, 100% there must be some kind of acceleration which is directed towards the center, acceleration which is directed towards the center. Who will give that acceleration? Because that block is touching, the block is touching that curved surface, 100% there must be some kind of normal force towards the center. Hence, that normal force is that mass of that particular block, whatever that m mass is, into the centripetal acceleration. Okay. Now, what is centripetal acceleration? It is v square divided by the radius. Clearly, you can see the v square value is proportional to the normal. N is proportional to square of the velocity. If normal is proportional to square of velocity, as velocity doubles, normal will become 4 times. Velocity becomes 3 times, normal will become 9 times. So, it will be a parabolic curve. Obviously, this graph, what is this telling you? It will be an upward parabola. It is a square proportional. It will be upward parabola. It will be an upward parabola. So there is only one graph like that. Yes, Rama, perfecto. The correct answer is option A. It is an upward parabola like this. Okay. So these are some of the standard questions on direct centripetal force. See, it's not like you don't get complicated questions, but since I just taught you to centripetal force, I'm limiting myself to just centripetal force related questions. Obviously, we will solve mixed questions when we start with practice questions in some days. Okay. Now let's talk about centrifugal force because that is another aspect of this chapter and students think centrifugal and centripetal are very similar, just equal and opposite, and lot of misconceptions are there. Okay, first of all, whatever problems we did till now, okay, whether it is this problem or 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 this problem or this problem, all these problems were done in a inertial frame. That means I was just standing outside on the ground or earth and I was just looking at it go round and round, right? So I saw that particle doing a circular motion or taking a curved path. But imagine I relocate and change my perspective and I become a rotating frame. Okay, I'm not a ground frame, I'm not an inertial frame. If I was inertial frame, I'll just see it go round and round like this. Okay, I will see it go round and round like this. It will go around me. But if I am a rotating frame, then things change. The perspective will change. It's like, look at it. Imagine there is this particular disc, merry-go-round like. Okay, just imagine this merry-go-round and this particular merry-go-round has some kind of axis like this. And on that merry-go-round, there is this champa who is standing on the edge. This champa is standing on the edge, and that merry-go-round is rotating. Let's imagine two Pandus or Pandu in two scenarios. First time, Pandu is standing on the ground. Pandu is standing on the ground and he is observing that particular champa. Pandu is standing on the ground and he is observing that champa. He's like, wow, what a nice champa. Second time, the same Pandu is on the merry-go-round, observing the champa. What will be the difference in what he sees? In the first observation, the Pandu sees the champa performing uniform or circular motion. So for this particular Pandu, the champa's path, the path is circular. Path is circular. And there is motion. There is some kind of motion. But in the second scenario, when Pandu is on the merry-go-round, he will see Champa in front of him. Just visualize, and he will see the entire world revolving around Champa and him. It's like a very romantic poem kind of a thing, or a very romantic scenario you can think, where Pandu is on the merry-go-round, he is looking at Champa, Champa is looking at Pandu, and the whole world is revolving around them. For Pandu, Champa is at rest. For Champa, Pandu is at rest. Agree or disagree? For both Pandu and Champa, they are at rest with respect to each other. Are you able to visualize this? mg is also acting in the previous example, but that mg might be balanced by some kind of friction maybe, and it is not in the direction of centripetal in the previous example. That's why I did not consider. Okay, it was irrelevant in that direction, in the horizontal plane. Good evening to know. So in this particular scenario, the champa will be at relative rest in this scenario. If you ask me what are the forces, well, normal is there, mg is there, but I'm not interested in normal and mg because they are not in the direction of acceleration. So I'll just ignore that for now. But here I know for sure there must be some kind of frictional force. Do you agree with it? Champa's feet will experience friction. Without friction, Champa would have been thrown out. She would fly out. Friction will be directed towards the center. And I know it is towards the center and not outwards because there is centripetal acceleration over here. And then I will say that Pandu will write the equation like this. F is equal to mass into centripetal acceleration. And then he will substitute the value of acceleration as omega square into r. Omega is the angular speed, r is the distance at which Champa is standing from the axis. So F will be m omega square r. That is the equation which Pandu will write. This force is the centripetal force, which is providing the necessary centripetal acceleration. Centripetal acceleration. In this case, what will Pandu say? The Pandu will see that Champa is still experiencing a force towards the center, which is the frictional force. But the problem is mass into what is the acceleration? It is zero. That is the problem. That is the problem. The Champa is at rest. So RHS is zero. LHS should be zero. But I know friction can't be zero just because Pandu changed the observing frame. Agree or disagree? Just because you change your frame does not mean friction will stop acting. Friction, if it was acting, universal truth, it will be acting no matter where you look at it from. If a force is acting, normal friction, spring force, tension force, any force, it doesn't depend on the observer. It will be there always. So how is it that Pandu is concluding something different over here? So this particular rotating frame has some problem. So this is not making sense to me. Okay, this is definitely not equal to. There is something wrong going on over here. So this scenario over here, my dear students, was actually where the motion happened. This is basically a inertial frame. This is basically an inertial frame of reference. This particular frame is non-inertial in nature, non-inertial rotating frame. Rotating frame of reference. This is a non-inertial rotating frame of reference. And whenever we have non-inertial frames, Newton's laws are invalid. Newton's laws of motion are invalid. So we deliberately make it valid on paper just to satisfy our ego of keeping or respecting Newton. And what we do is we say that apart from that friction, there is an additional force, and that is our pseudo force. So this is not a real force. This is pseudo force. I'll put FP over here. So F minus FP, that now, because there is no relative motion, I will say is equal to M multiplied by 0. Now this makes sense. Yes, my force of friction and pseudo force are balancing out each other. This is called as the centrifugal force. This is a pseudo force. That pseudo force is called as the centrifugal force. So centrifugal force will come in a non-inertial rotating frame. And in that non-inertial rotating frame, you will not call friction as centripetal force, nor will there be any kind of centripetal acceleration. Please understand this very carefully. In inertial frame, centripetal force came, centripetal acceleration came. The moment you are rotating and seeing it at rest, gone. Centripetal force has gone. You cannot call friction as centripetal anymore, nor is the motion circular. You are seeing that champa or that object at rest. So because you're rotating, you will experience an outward force called as the centrifugal force. So now this is what that equation will be. So you can now write Fp as m omega square r, that is the value of the centrifugal force. This will be equal to 0. Tell me, are these two equations same or no? Are these equations same or no? Now Newton's laws of motion are valid, but you will notice that this equation or even this equation, both of them are actually the same. Both of them are actually the same equation mathematically. Just take m omega square r left side or right side, that's it. Yeah, isn't it? Yes. So my dear students, mathematics, if you ask Ninja ma'am or any mathematics teacher, they will say x is equal to y or x minus y is 0. Both are same. But from my perspective, from physics perspective, I have some reservations here. Meaning, when I put the same term on the right hand side, it becomes the effect part or the acceleration part. But that same term, when I shift it on the left hand side, it is then considered as a force. So whether you write x equals to y or x minus y, mathematically is the same, but in Newton's laws perspective, physics perspective, left hand side is force, net force, right hand side is mass into acceleration, which is the effect of that force. So when you put that y on right hand side like this one, it is the effect of this force, but when you shift it on the left hand side, then this is considered as a force, and the net force is balancing out each other, so it is zero. It is not giving any effect. Are you understanding it? Mathematically same, but physics wise there is a difference of the placement of understanding. Is this absolutely clear? Here, this is the effect. This is the effect. Here, this is the cause. This is the same term becomes the cause, or basically a force. Cause means the reason. Okay? Very, very important understanding. So, what is the formula definition centrifugal force? So, I will say like this. A rotating frame is non-inertial in nature, therefore you must consider a pseudo force, that is the centrifugal force, and this force, centrifugal force, acts radially outwards. So if I have a frame of reference like this, and this particular frame of reference is rotating, and I am looking at some object, maybe over here at a distance of r. It has some kind of mass, then the centrifugal force on it will be radially outwards. There will be other forces also, not showing that. Okay, it could be anything, just showing some forces, but I'm mainly considering the centrifugal force exclusively over here, which I want to show. The centrifugal force will always act radially outwards, and this centrifugal force magnitude is mass of the object, so m, and then you have angular speed, which is omega square into the radius, that means the distance from the axis. So this is the formula for centrifugal force. Of course, it also acts radially outwards, that gives me the direction. These are the two important things. Is this absolutely clear, everyone? What is the formula for centrifugal force and how to consider it? It will just be a part of the free body diagram, and other forces will still exist. Like over here, friction was still existing. You just are adding one extra pseudo force. That's it. Very underrated concept. Yes, very true. So, whenever you are sitting in a car and the car is turning, or the bus is turning, or the bike is turning, okay, whatever vehicle you are sitting in, you feel you are thrown out. Actually, nobody is throwing you out. Imagine if I was given a push, somebody gives me a push, tuck. What I will do? Newton's first law. I'll just keep going like this, tuck. Assuming everything is smooth surface. Okay, I'll just keep going, straight line, uniform motion, isn't it? Somebody pushes me like this, I'll keep going straight. So everybody has a tendency to maintain its state of rest or inertia. So somebody gave me inertia, motion. So I just keep moving uniformly with constant velocity. I have no reason to change my direction. I cannot just go randomly here and there. There is no reason for me to turn. Everything is smooth. Now imagine somebody at the center gives me one string, like this. They give me a string and I hold that string. So as I was moving like this, because I'm holding the string, now slowly I will turn. Slowly I will turn, isn't it? So that tension was causing that acceleration towards the center. If you look at it in the non-inertial perspective, I will say for that person, I would be at rest. That person will see me at rest. The whole other world is revolving, and he will say, Why is it that you are at rest and I am experiencing this tension? Oh, I am non-inertial. So this person is experiencing an outward centrifugal force which is balanced by the tension force. That's what that person will experience. So without the tension, I would have just gone in a straight path. That tension is causing me to go in a circular path for outside frame, but for the non-inertial frame, the tension is just balancing the centrifugal force, which is that outward nature of push, which I will feel like it is there as I turn. I will feel I'm going to fall out. Yeah, that's what I'm going to feel. Okay, perfect. So, can all these problems be then solved via centrifugal force also? Yes, even this problem can be solved via centrifugal force. Just think about it. Okay, just think about it. Even this particular problem. Imagine I had to just solve the same question via centrifugal force. Okay, what would I say? Oh, it is going round and round. I will choose a new frame. And how is my frame? It is a rotating frame. It is a rotating frame of reference. So I'll choose a rotating frame of reference. So in that rotating frame, I will see, okay, normal though is anyways going to be there, but there will be an additional pseudo force. There will be an additional pseudo force. And this block will appear to me at rest because as I rotate, the block is just in front of me. The block is just in front of me. So the block is in front and everything else is rotating. Oh, okay. So I'm just going to say that the normal force is just balanced by the pseudo force and that is equal to m multiplied by 0. So therefore, normal force is equal to that pseudo force. It is balancing. Pseudo force is mv square by r or m omega square r, one and the same thing. So as you can see over here, my normal force again, my normal force again is directly proportional to the square of velocity, exactly what we got over here. Same equation, answer will not change. Same equation, answer will not change. Yeah, it's just a different perspective of looking at things. So every problem can be solved via centripetal force or centrifugal force, but you should know when to use what. And sometimes some concept might be natural or very convincing rather than the other one. So you decide what is more convenient for you. Yes, giant wheel example is also an example of centrifugal force. Say for example, if I take a big giant wheel like this, a big giant wheel like this, and there are these cabins which are hanging from that giant wheel. Okay, imagine there is a person standing over here. Imagine there is a person standing over here. Tell me, guys, what is the direction of centrifugal force in all the scenarios? This is omega. Can you tell me the direction of centrifugal force in all the scenarios? I know mg will be there in all the scenarios. So I'm just showing the basic forces first. mg, 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 mg. Normal will also be there. Yeah, normal can't go away. Normal, normal, but I feel the normals will also be different. So I'll call this N1, then I'll call this N2, and I'll call this N3, call this N4. Yeah. And we are looking at it from non-inertial perspective. So imagine a rotating frame of reference, non-inertial in nature. So where is the centrifugal force going to be? Every time radially outwards. So this case, it will be like this. This case, it will be outwards like this. This case, it will be this way. This case, it will be like this. Is it true? Yes or no? Come on, quickly think and tell me. Yeah. Now, the real question is, here I can see that my pseudo force along with the normal is balancing mg, sir. So normal is basically mg minus my pseudo force. Yeah, in the first case. Here I am seeing, sir, the normal force is upwards and it is balanced by mg down. and also the pseudo force. This is how the balancing nature is. So therefore, if you ask me what is the value of N3, I already know it is mg plus F3. In this case, I can clearly see N4 is equal to mg, and here also I can see N2 is equal to mg. Pseudo force has no role to play. Oh, so the normal force, that means the force which the flooring of that giant wheel cabin will exert on me, is changing. Where is it highest? Where is it lowest? And where is it the true weight? As you can see over here, this particular scenario, it is showing the true weight. You are experiencing your true own weight. If you are 60 kilos, you will feel that the normal by the ground surface is basically what you would normally experience. So you will experience true weight at both these places, at the horizontal place from the center, at this place and at this place, both the places. But here, the normal is mg minus fp. So this clearly tells that this is lowest of the entire circular path. This is mg plus fp, not minus. So this is basically the highest normal which you will experience. Meaning, in this entire giant wheel, you will feel something is happening in your stomach, and as if you are losing weight. That happens at the topmost point, because as you go on the top, normal will reduce. So when normal reduces, your brain feels as if the flooring below you is disappearing. Normal is reducing, so you'll feel little bit weightless, and that's why you will feel something in your stomach. And when you go below, here the normal is the highest. You will feel somebody is pushing you. The normal force is lot. You will feel the ground is crushing you with your own weight. So the highest weight will be at the bottommost point. So next time when you are on a giant wheel, please carry this weighing machine. Yes, I'll just show you the weighing machine. I have this amazing weighing machine, which I'm going to use it for my physics experiments. And maybe someday when I go to the giant wheel, I'm going to carry this weighing machine and I'm going to see my weight. And if I stand on this weighing machine, 100%, I'm going to see my true weight at these two places. At this place, I will feel lighter. If it was 60, it will show me 58 or 56. Over here, instead of showing 60, it will show me 62 or 63 or 65, like that. Okay, got my point? Yeah. So this is the concept of the centrifugal force in a giant wheel. But then there is one question which is unanswered. It's not related to that normal. It is at these two places. Sir, centrifugal force is there here. So who is balancing, because this dude is still at rest? Oh, right. You're so correct. Who is balancing the centrifugal force? Normal and mg can't. So there must be something inwards. Guess what it is? It is the friction. Yes, without the friction, you will start slipping inside that cabin. So because of the centrifugal force, imagine if friction was not there, everything was smooth, you will go and bang on that dish, the right door or the left door of that cabin. Over here, centrifugal force will push you out. So you'll start sliding and you will hit the surface on this side, because friction is not able to prevent you from sliding. So friction is needed, else you are going to slide and hit the left or the right side of the cabin. Okay, such an amazing concept. So I hope you understood the concept of centrifugal force. And please don't say centrifugal force is action, centripetal is reaction. Newton's third law. Yo. Don't say such things. All rubbish. Okay, they are not action reaction. They are not equal opposite. Don't say such things. They are completely different in different frames. If one is there, the other is not there. All of that. Okay. Cool. So let's start solving some questions. JEE 2023. See how Laddu questions have come. There is a child of mass 5 kilos in a merry-go-round, one rotation in 3.14 seconds. The radius is this centrifugal force. Can you believe this question came? How much is the centrifugal force? So the centrifugal force is m omega square into r. Okay, mass 5 kilos, omega not given, radius 2 meters. So first thing, I'll find omega. one rotation in 3.14 seconds. One rotation means 2 pi radians in 3.14 seconds. Therefore, omega, which is angle covered by the time, will be 2 pi by 3.14. But pi and 3.14 are the same, so it will become 2. So 2 radian per second is the omega. So substitute that over here. But do not forget, you have to square it also. 2 square is 4. 4 2s are 8. 8 5s are 40. So 40 Newton is the answer. Yeah, everyone got it? Okay, yes, option number D, 40 Newton is the correct answer. Perfecto. Let's go. Yes, Rama, Arvinda, everyone, come on, keep answering. Arvinda, good evening. Actually, I've covered 40% of my syllabus. I need to complete the remaining 60%. Would you recommend me to watch the Roar series? Arvinda, don't go after completing 60%. Even if you do 70% of the syllabus, you are still at a great position, trust me. But make sure whatever syllabus you are doing is high weightage. If you want to know what is high weightage, go down in this particular lecture description box. Just click on the Ekalavya test series link. Okay, the test series is for 1999. Many kids are already subscribed to it. If you have not yet, please do that. Okay, or else you will stay behind. Make sure you are going down and download the high weightage topics. I have mentioned the high weightage subtopics, not chapters, subtopics. Make sure whatever you are doing is at least high weightage. This much you should do. This should be 100% because that will take you to 99 percentile. Else, if you are doing 40% of the syllabus, but it is not high weightage, then you will not even get 80 percentile. Because I'll tell you, these high weightage topics are just 25 to 30% of the syllabus. So just imagine, even if you have not done 75% to 70% of the topics, still a student can get close to 99 percentile. Yeah, that is the importance of this particular PDF. Okay, so make sure you are going to it, or else it will be a big blunder. Yeah, great. Moving on to the next question on your screen, and here it is. What do we have? A coin is placed on a disc. The coefficient of friction between the coin and the disc is given to be mu. If the distance of the coin from the center of the disc is r, the maximum angular velocity which can be given so that the coin does not slip away. Okay. So first of all, let's visualize our disc, which is like this. Okay. And this is axis maybe. Okay. And then we'll show the coin somewhere over here. This is the coin which is placed over here. Okay, this particular coin is having some mass maybe, and it is at some distance. What is it? R. Okay, and it is rotating with some angular speed. Okay, these are the things. Now there is some coefficient of friction also given. Okay, we'll see how it is useful. What are the forces? Normal will be there, 100%. The weight will be there downwards, so mg is there. And because it has to go towards the center, obviously friction will act towards the center. If you are not able to visualize it, no issues. Think like this. In the non-inertial frame, centrifugal force will act like this. It will push it out. So prevent it from flying out. Who will balance it? Friction will balance it. So that is how you can visualize it. And this force will be static in nature because it is not slipping. Now, obviously, in the vertical direction, N minus mg is 0, or basically N is balancing mg. And in the horizontal direction, my static friction minus Fp is 0. Therefore, static friction is being balanced by pseudo force. Pseudo force is m omega square r. Static friction maximum value will be mu n. N is nothing but mg. So this is m omega square r. Mm cancels. So mu g is equal to omega square r. But what do I want? I want the maximum angular velocity. So omega square, take r below, mu g. So mu g divided by r. Therefore, omega will be root mu g divided by r. This is the maximum limit of the angular speed. Anything more, it will be too much of centrifugal force, which will make it slip. So this is limiting angular speed. Okay, mu g by r under the root. Is this absolutely clear? Option number 3. Very good. Excellent. Okay. Perfecto. Great. Great. N2, N3. Bro. Who is this bro, Sanjay? I don't see any bro in the video. So it is your sir. Okay. Yeah. Awesome. VAR, these are all lectures which are being taken right from the basics to the J level. So if you have joined in little bit late, I would suggest that you watch from the beginning. If you have missed the previous lectures, watch that. Else, you will feel that you are, you know, uh, finding the things fast. So I would suggest you watch it from the beginning. Okay, let's go to another question. And you can see this particular question also very similar. So this is your homework question. I just wanted to show you. See again, repeat model. Repeat model. This model getting repeated again and again. A coin is placed, slips at a distance of 1 centimeter. Angular velocity of the disc is half. Then it will basically slip at what distance? Same model of the question, guys. Same model of the question. Same equation will be needed. So you can see it's a repeat question. So try to do this as homework. Try to do this as homework. All right. In fact, one more homework question. Again, you can see repeat of the same model. Same model again getting repeated. So this also, please take it as homework. Okay. I've just shown you how to do it. The same thing, just asked in different ways. This is what I say, solving a model of a question. This is a model, different ways it is asked. So anytime, any type it is asked, you should be able to do it. You cannot say, sir, I know this, I don't know that. No, try it out. Okay. You will get full confidence. Great. So let's go to another question coming up on your screen, and here it is. What does it say? A block is attached to a spring, length of 20 centimeters. The other end is fixed at a point. The block moves in a circular path with constant angular speed about that point A. The tension in that spring is how much? This is a beautiful question because there is a good chance of making a silly mistake. I think I know that might be the catch in the problem. Let's see whether it is exactly what I'm thinking. Okay, so let's imagine our block. Our block is somewhere here. Okay, this is our block whose mass is 100 grams. That means 0.1 kg, and it is attached to this particular point with the help of the spring. Okay, now it is made to go in a circular path with an angular velocity of 5 radian per second. So if you want to do it the centrifugal way, then there will be a centrifugal force that is in the non-inertial frame like this. And to balance that centrifugal force, obviously there should be a force of the spring. The spring will be extended in nature. So force of the spring balances the centrifugal force. And if you are in that rotating frame, you are going to see this particular mass at rest. So I'm just going to say the forces are balancing each other. The spring force minus Fp is equal to m multiplied by 0. Do you guys agree with this statement? There is no acceleration, no centripetal, because I'm in the rotating non-inertial frame. So I'm just going to see the mass in front of me. So it is at rest for me always in front of me. Everything else is moving. Okay. So take that pseudo force on the other side. So it will be Fp, and the value of the pseudo force will be m omega square r. Okay, we'll come to that. Spring force, keep it like this. Now, what is the value magnitude of the spring force? It is obviously kx. What is the value of the pseudo force? It will be m omega square r. Now, I think the next catch is there. After this basics, spring constant, I already know. Spring constant is already known. It is 7.5. Question is, then the tension in the spring is asked. Oh, the tension in the spring is asked, meaning the spring force is asked. So I don't have to think too much. Okay, over here. I'll tell you what. I have been asked exactly the spring force, which is the tension in the spring. But the problem is everything over here. Mass is zero point 0.1, omega is 5, so 5 square. Lot of people are going to think the radius is 20 centimeters. How many of you thought the length of the spring is zero point 0.2 meters? That means radius will be also zero point 0.2. That is the wrong part. Yes, that is the wrong part. Can you guess why? The original length was 20, but after it begins to rotate, won't the spring get extended? So how can it remain 0.2 meters? So 100%, the older length would have been 0.2 maybe, but there will be some extra extension also. There is some extension in the spring also. So a lot of people miss that r plus x, or original length plus x, which means zero point 0.2 plus x. This is the crux of the problem. Got it, everyone? Yeah? Amazing, amazing, amazing. So now you'll be like, sir, now though I can't find spring force because x is really not known. How much is the extension? Is it given? Oh my God. Maybe that's why spring constant is given, because I know this will be kx and k is 7.5 and x I do not know. Maybe I have to solve this equation. So 7.5x is equal to, what is this? 5 square is 25. So this will be 2.5 multiplied by zero point 0.2 plus 2.5 multiplied by x. Bring that x on this side, 2.5x on this side. So 7.5x minus 2.5x is 2.5 into 2 is 5, but point is there, so it will become 0.5. 7.5 minus 2.5 is 5. So 5x is 0.5. Therefore, x will be 5 cancels. It will be 0.1 meter. So we found the extension. That is a very beautiful question which was asked in 2023, not the normal time. Now we can find how much is the tension. Where is it? The tension in the spring is asked. So remember, the tension in the coil of the spring is the spring force itself, which means it will be just kx. So k value 7.5, x value 0.1. So it will be nothing but 0.75 Newton. So 0.75 Newton means option 2. Understood? What is the crux of the problem? Yeah. So the answer is 0.75 Newton. Beautiful question, guys. The catch was here. I did not know the extension. A lot of people even miss this X and they write directly this as the answer, which is completely wrong. Beautiful. AC JEE videos, alternating current I have already done. If you are in that urgency, you can definitely go to the channel and you can go search alternating current. Alternating current. Yeah, you can just search for the videos. It is right over here. You can watch the one shot video, or you can watch detailed playlist is also there. Alternating current. You can see 6 videos are there. The entire playlist is over here. Please check it out. Okay. Perfect. Okay. Now let's go to the next part. 3 specific problems I'm going to take: conical pendulum and then the curved motion along a road. Okay. So first is conical pendulum. What is this conical pendulum? Conical pendulum means you are hanging something and then letting it rotate. So the motion looks like it has been tracing the surface of a cone, curved surface. So that motion is called as conical pendulum. Simple pendulum means you just pull it and leave it. It goes back and forth. It oscillates. That is simple pendulum. Conical pendulum means you give it a push like this, it will go like that. So the thread will go retrace the curved surface of a cone. So it will look something like this. Observe. like this. This is how it is going. Okay, so this is how it is going, guys. Okay, in a curved path, as you can see, right? So this is tracing the curved surface of a cone. So that's why it is called as a conical pendulum. Usually, what is given to you in such questions, I'll tell you, length might be given, mass might be given. Okay, that's it. And maybe omega is given or asked. Then either theta will be given or it might be asked. Okay, so last thing is, like I said, omega. These are the variables that you generally deal with in the question. Now, you can visualize it by past experience. If you have rotated something hanging like this, if you rotate it fast, then the angle made will start increasing. If you rotate it slowly, then it will go in a small cone angle. But if you increase the angle, it will go on a big conical angle. Yes or no? Thank you, Charan. Means a lot. Keep watching, keep learning, keep enjoying. Okay, God bless you, my dear. So, as you increase the speed, the angle will also increase. Okay, perfect, sir. So, what are we exactly looking at? We're trying to see if these variables are related to each other and what's the relationship. So, let's think about the forces. A force of gravity will be there. So, mg I should put. Then tension will be there like this. But I know this tension might have to be split in the next step. So, I'll just put it as a dotted line over here. This tension, I'll split it into two components, one component like this and other component like this. Because this is theta, it is also obvious that even this angle will be theta. So the closer to theta will be T cos and the farther component will be T sine theta. This will be some kind of radius in which it is going. The last thing, if you want centrifugal, you can put, or you can also put centripetal acceleration also, one and the same. So these are the only forces acting on it. Nothing else is there. Okay. Now let's see what all equations I can make. First, in the vertical direction, in the y direction, I can see my t cos theta minus mg, there is no motion at all. Therefore, tensions cos theta is being balanced by the own weight. In the x direction, t sine theta will act like the centripetal, will act like the centripetal force, centripetal force, which is giving that particular mass the centripetal acceleration. Okay. So therefore, T sine theta will be mass into centripetal acceleration. I know centripetal acceleration will be omega square multiplied by r, but the problem is what is r? Okay, what is r? Let's think, let's use geometry. If you use geometry over here, r is opposite to theta where L is the hypotenuse. So sine theta will be opposite side by hypotenuse. Therefore, radius is L sine theta. So why not put the radius itself as L sine theta over here? Okay, so I just substituted the value of acceleration as omega square r, where this is L sine theta. Oh, the best part is sine theta and sine theta just got cancelled, and I am left with the tension value as m omega square into L. What a nice answer. Tension is m omega square L. Please by heart this. So whether it is horizontal circle or whether it is conical pendulum, the tension is always m omega square L. So forget about mg in all such scenarios. Even if it is horizontal circle or conical pendulum, tension is m angular speed square into the length of the string. That's it. Tangential acceleration is not there right now because, it's a uniform circular motion. For tangential acceleration related concepts, we are going to spend the next class, the third class and the final class, okay, where we'll discuss only non-uniform motion. Now, using this tension over here in this particular equation, basically, actually this particular equation. If I substitute the value of tension as m omega square L and multiplied by cos theta, that will be equal to mg. So cancelling out mass from here as well as here, what do I get cos theta as? I get cos theta as g divided by omega square L. What an answer. So I got the relationship of the angle and the angular speed. Theta is related to angular speed. When theta changes, omega changes. Beautiful question. So please remember both these formulas. Okay, remember both of these formulas. Great, very nice. So let's go to the question based on this. Let's go to the question based on this. Let's see. It was asked in JEE 2023. A stone of certain mass is tied to the massless string or string length 1 meter. The breaking tension is 400. The maximum linear velocity the stone can have without breaking the string while rotating in a horizontal plane. Okay, so this is again a question of conical pendulum only. This is again, okay, master string, the breaking tension is given, the maximum velocity can have without breaking the string in a horizontal plane. Oh, but the best part, it is rotating in horizontal plane. So, I mean, then not even have to worry about conical pendulum, guys. It's just simple tension and simple acceleration related question, and tension will always be m omega square L. That's it. But here the question is not omega, question is v, and we know that v is equal to omega L. So therefore omega will be v by L. If you substitute that, you will get m v square by L square multiplied by L, which makes it mv square by L. That is the value of tension. So tension is given to be maximum 400, mass is given to be 1 kilo, velocity is asked, length is also 1. So v square is basically 400. So therefore v is 20. So answer is 20 meters per second. Very simple and straightforward. Even if this question did not mention horizontal plane, still it will be the same thing. Okay, don't worry about it. Option A. Yeah. Is there any batch for 2027? Right now we have the pro badges, but very soon we'll be, I mean, in couple of months we'll launch the 2027 batch also. This time we'll do one thing though. Last year I would admit that we made a small delay in starting the batch. I mean, we launched it only late because I don't know, for whatever reasons. We launched it in May, and the batch started in May and or June. This time we'll start it early, maybe in April only. Okay, it all depends on your love and support. And maybe for 11th standard, 10th moving 11th also, maybe we'll start a batch soon. Okay, cool. Yes. Sir, is it possible to show SHM? You mean the lectures of simple harmonic motion? It is here only. Just search for, I think it should be by the name of SHM or oscillations. Okay, oscillations last year was done by Madan sir in roar part. But if you want my detailed, this was revision with questions. You can watch this class. If you want the playlist, it is right over here. Okay, you can see this one. These are the classes. Okay, simple harmonic motion, lecture 1, lecture 2, and all of that. Okay, so I have done it. Lecture 1, this is lecture 2. Yeah, just check that out. Okay, perfect. Rama? Okay. Now, the two last questions or concepts. First one, you're going on a curved track and you might have felt that you are going to skid off and fly off. Have you felt that inner feeling? Because of centrifugal force, pseudo force. I'm going like this, I'm riding. I feel that I might skid and turn over here. Why? Because as I turn, the center is somewhere there and centrifugal force is outwards. So I feel like I'm going to skid. So friction will act inwards and prevent me from slipping. So I want to know what is the maximum speed limit. You might have seen some speed sign. Do not cross this speed, or there is a limit. Why is there a limit? We can easily understand it. by a simple free body diagram. So let's see that first. Say you have a vehicle like this whose mass is m and it is going on a curved track like this. The radius of that curved track is, let's say, r. This is the center. There will be multiple forces on that vehicle. Its own weight will act down. The normal force will act upwards, and the friction will act towards the center, which will be static in nature. And there will be pseudo force which will act outwards like this, as you can see. In that rotating frame, if you take the rotating frame of reference, you will see that this particular mass is going to be at rest. Is that so, everyone? Yeah, this is also a favorite part of NTA. Correct, very true. So many questions came. Neat concepts for physical, sir. Can you? For physical means cool. What do you mean by physical? For physics? Uh, See, the paper level was very good, especially in 2025. So I would suggest you should practice some good questions, long questions, uh, lengthy questions, calculative questions for CBSE, number one. There is that initial part which has some objective questions, thought-based, reasoning-based also questions. For that part, although board level is enough, but additional JEE and NEET knowledge helps you in solving those questions. Also, there were many questions on reasoning based and everything. There also JEE and NEET studies helped for the CBSE aspirants. So that way, the CBSE physics paper was actually tough, and it is expected that next year, 2026, 2027 also, it will be good. So yes, it helps, but you cannot just depend on JEE and NEET studies. You have to practice CBSE related questions also. Okay, case studies and everything. You should be having that habit of writing, completing the paper on time. Last year, many kids didn't complete the paper on time, made a lot of silly mistakes in calculations. Okay, didn't know how to answer specific type of questions. So that's where you need that extra practice for boards. So over here, it's obvious that normal force is going to balance mg. They are balancing each other. In the horizontal direction, the static friction is again balanced. It's again balancing each other. Okay. What is the value of pseudo force? It is mv square by r. This is static friction. Okay. Now you can see that when my speed will increase, my friction will also increase. If I'm going at a higher speed on this curved road, what will increase? Radius can't change, mass can't change. So friction will also increase. Now that should ring a bell in your head. Friction can't just increase beyond a certain limit. There is a maximum limiting friction. That's why there is also a limit on the maximum speed. So when you try to calculate maximum speed, the friction will also be limiting in nature. For normal speeds, it will be static, but for maximum speed, it will be limiting friction. So this will be mv max square by r. Fs max is mu multiplied by the normal force is mv max square by r. And the normal force, obviously, we just figured it out. It was m into g. So mv max square divided by r. As you can see, this mass and this mass just got cancelled, and we just got V max square. V max square is mu s g multiplied by r. Therefore, V max is root mu g r. That is the final answer, which you should remember. So usually they will give you mu g r and find v, or v is given, mu is given, g is given, find r, or v is given, r is given, g is given, find mu. Very direct question. Better remember this, and also how it is derived. Okay. Yeah. Yes, perfecto, perfecto. Amazing. But you know what? You might have seen, even though they will put the limit as 60 and you are going at 50, it is very much possible that when you are going on that road, you will skid and you will fall off. You're like, why? Sir, speed limit was 60, sir. I went at 50, sir. How come I skid? How is it possible? Cheating, sir. Government cheated me. That person who put that board cheated me. I fell down. Not actually. Because I'll tell you why. This maximum speed is dependent on radius, which can't be changed. Gravity, I can't change Earth. I'll have to go to some different space planet. Not possible. Mu, oh, that can change. Maybe when I was going on this road, the road had developed some kind of rubble. Some sand was spilled, some oil was spilled, or it rained. The road became wet. Or my scooter tire or car tire has become worn out. So the rubber is not of good quality or it has been used many times. So that means mu can change. And if mu is less, maximum speed limit will also reduce. But then the problem is, I do not know what things can go wrong. Somebody will spill oil, somebody will pour water, the ground might become loose, okay? Tire might be worn out. So mu can reduce drastically. If mu reduces drastically, my speed limit will also reduce drastically. Then it will become, instead of 60 kilometers per hour, it will become 5 or 10 kilometers per hour. You think I am such a waste fellow that I will go at 5 or 10 kilometers per hour on this road? No, I want to go zooey. I want to go fast. Yeah. So I don't want to go slow. So what to do now? What to do? The problem is I was dependent on a unreliable person, which is friction. Unreliable person, not so reliable. Sometimes friction is there, sometimes tire gets worn out, oil spills, rain comes, gone. Friction will tell, sorry, I can't help you. I can't give you the acceleration towards the center. So what to do? In exam also, or before the exam, you will not call unreliable person, you will call reliable person. Who is that reliable person? Can we invent a new force? Magnetic force, sir. Sir, we'll put a magnet, sir. We'll get magnetic force. What nonsense. Electric force, spring force, tension force. No, we can't get new force. Whatever it is, boss, adjust between them. MG says, boss, listen, I can only act down. Friction says, I can only do so much. The only person left, normal. So you go to normal and say, normal, normal, please help me. I need centripetal force or I need to balance centrifugal force. Normal, you'll be like, don't worry. But you'll be like, how? Normal is up. It is not having any component in the pseudo force direction or in the horizontal direction. I got an idea. How about taking this normal and making it at an angle? I can't make it completely like this, else the bus or that car will be going weird way. But when the normal is at an angle, then a component of it will balance the pseudo force. Meaning you tilt the road. That road is called as a banked road. It is called as a banked road. You can't change the radius, you can't change g, you cannot change mu or can't depend on mu. So you depend on the norm. So when such a scenario happens, the normal force is at an angle. A component of that normal force will give that acceleration, or I will say it will balance the centrifugal force. Can you now visualize this? Normal is a dependable force. So that is why you bank a road. And when you bank a road, this is what happens. Observe this carefully now. This is a banked road. So the forces are mg, then normal, but normal is going to be split. We'll see that. Okay. And of course, pseudo force outward like this. Okay. This is the angle of banking, theta, by which you have turned the road by an angle. Okay, normal is there, mg is there, and this is your pseudo force. I'm assuming non-inertial frame of reference. These are the forces, guys. That's it. But if I try to go with lot of speed, then I will be pushed outwards. So there will be a tendency to fly out. So that is the reason why frictional force will also come into existence, and friction will prevent me from slipping like this. So there will be friction also like this. And when I go with maximum speed, this friction will also be maximum, Fs max. Okay, I'm trying to go with maximum speed. So there will be a tendency, to fly out, or to tendency to skid outwards. So that is why friction will oppose that tendency when I'm trying to go with maximum, pushing myself maximum speed. Okay, so these are the forces in such a scenario. Centrifugal force, we already know the value of it. It is m v max square by r. All these forces will be balanced, and you can resolve the forces and then solve the question. Okay, you just have to resolve the forces and just solve the question. Like I feel here normal and mg you can split it up into two components. One component will be in this direction, other component will be this direction. Then even the pseudo force, you can split it in two directions, one like this and other one like this. So that's how you split the pseudo force. This is theta. This will be Fp cos theta. This will be Fp sine theta. Okay. Then you will have mg cos theta over here, because this will be theta and this will be nothing but mg sine theta. So split the forces, resolve the forces, and just now basically write the equations. Like normal force will be balanced by mg cos theta plus the pseudo force part, which is Fp sine theta plus Fp sine theta. That is one thing. Then here in the horizontal direction, mg sine and F max, mg sine theta plus Fs max will be balanced by pseudo force cos theta, Fp cos theta over here. Perfect. Now Fs max is nothing but mu into n. So mg sine theta plus mu multiplied by n will be Fp cos theta. Therefore, mg sine theta plus mu into what is n? N is this. Okay. This first equation, we got it. How? In the vertical, perpendicular to the plane. This was perpendicular to the plane motion. This was parallel to the plane motion. So take this n and just substitute it over here. So when you substitute it, you are going to get mu into mg cos theta plus mu into Fp sine theta. This is equal to Fp cos theta. Take Fp on the same side. So you will get mg sine theta plus mu mg cos theta will be Fp cos theta minus Fp sine theta into mu. So this will be mu Fp sine theta. Okay, so over here mg is common. So this will be sine theta plus mu cos theta. Fp is common. Fp pseudo force is mv max square by r. mv max square by r, and we have cos theta minus mu sine theta. Okay, cancels. So therefore v max square will be, r goes on the top, g is on the top. We have sine theta plus mu cos theta, whole thing divided by cos theta minus mu sin theta. So from this we can get the maximum speed, but I won't be happy with this because it's a very bad looking formula, and this is what is there in your NCERT, and that is what I don't like about it. See guys, in this particular question, when you're trying to find the maximum speed, yes, you can just take the square root of this and you can stop over there. But I feel we can slightly make it better looking formula. So V max square will be, do one thing, divide numerator and denominator with cos theta. Okay, divide it with cos theta. So it will look like this: sin theta by cos theta plus, look at it, mu cos theta by cos theta plus mu cos theta by cos theta, whole thing divided by, again over here, cos by cos, cos theta by cos theta minus mu over here, sin theta by cos theta, sin theta by cos theta. Now it looks slightly better. You will see why. This will become Rg. Sin by cos is tan theta. Mu cos gets cancelled, so it is just mu upon cos will cancel. It will become 1, and this will become mu tan theta. And that is V max square. Therefore, V max will be root just Rg tan theta plus mu upon 1 minus mu tan theta. This is a much better looking formula. So better to remember this than anything else. What kind of questions you'll get? Theta is given, mu is given, G is given, R is given, find V max. It's a very laddu type question. Okay, so this is a derivation for it. And as you can see, this is much larger than the speed for an unbanked road. Vmax was just mu Rg, Here it is mu plus tan theta. So numerator is big, plus denominator is even small. So it makes this very big. So the maximum speed on a banked road is much higher than a flat curved road. Got it? This is the idea behind it. But you know what? Even on a banked road, the maximum speed which you get might be used for racing cars, but for a normal passenger vehicle or a truck or a normal bus, you will not go with maximum speed because you are not racing, hopefully. You want the tires to be maintained. You want the tires should not heat up or else the tires might burst. You want the friction to be less as possible. So what you do is you try to drive the vehicle at an optimum speed. This is optimum speed so that there is very less wear and tear of the vehicle. And in such a scenario, you will see the friction will be absent, or you will not take help of any friction. You are just dependent on normal mg and your pseudo force. That's it. These forces are enough to balance the body. And when you again draw the FBD, resolve the components, FBD we have already drawn, and you write the equations, the optimum speed formula which you get, that's very important. The optimum speed formula that you get is just like this, but mu won't be there because friction is not there. Everything is same, this FBD and this FBD, except for friction is not there. So wherever you get mu, make it as 0. Mu is 0, mu is 0. 0 into tan, 0. 1 minus 0, 1. So denominator, forget it. Tan plus 0 is tan. So it is just Rg tan theta. That's it. So it is root Rg tan of theta. That is the answer. Optimum speed. Very straightforward. Got it, guys? So this is the kind of questions and concepts that are there in centripetal and centrifugal force. Sometimes they can combine this question with a train question also. They might tell you there is a railway track like this, and there is a train which is going like this, and it is told that, you know, this is at some height and the separation between them is L. Separation between the tracks is L. This is the train, and the train is designed to go at a particular speed. So the train is designed to go at a speed of V. So in such case, whenever that word designed to go on a particular track, banked road at some speed is given, this basically means optimum speed, not maximum. Lot of students have that confusion. It is nothing but optimum speed. So all you have to do is optimum speed formula, which is root RG tan of theta. Now the problem over here is that I do not know tan theta, but we can figure it out. As you can see, this particular angle will be theta, and tan theta will be opposite side, which is h, upon adjacent side, which is L. So it will be nothing but RGH by L. So that is what you are going to do in such questions. You will find very few questions like that, but if it is there, this is all that you need to do. Okay, very simple. I have given you a homework question already. So that was the last part of today's class. Last class, we will be hopefully doing it tomorrow or maximum Saturday, and we will be completing this chapter. We'll be doing non-uniform circular motion, relative angular speeds, the radius of curvature, and all of that. Okay. So see you guys. Have a great time. Take care. Bye bye. This was your Captain Shreyas.